In this video, we're diving into the heart of deep learning, neural networks, and some related terminology. We'll explore what they are, how they work, and why they're so important to AI. By the end of this video, you'll understand the basic principles of neural networks, and you'll be one step closer to becoming an AI expert. Plus, you'll finally understand what all those hidden layers are all about. A neural network, sometimes called an artificial neural network, is a type of computer program inspired by the human brain. It's a simplified way to mimic how our own brains function. Imagine a network of interconnected points. These points are called nodes, or artificial neurons. It's made up of these connected nodes that work together to solve problems. Now, it's inspired by the brain, but it's not an exact copy. Keep in mind, this is a highly simplified model. Real brains are far more complex. Our brains have billions of neurons connected in incredibly complex ways. Neural networks are much simpler, but they use a similar principle of nodes passing information. Each of these artificial neurons receives information, processes it, and then passes it on to other nodes. You could picture it like a team of people passing messages to each other. Each person receives a message, adds their own thoughts, and then passes it on. To understand how a neural network processes information, it helps to know that it's organized into layers, like the layers of a cake. There are three main types of layers: the input layer, the hidden layer, and the output layer. Let's look at each of these layers in a bit more detail. The input layer is where the information comes in. Think of it as the eyes and ears of the network. For instance, if you're showing the network a picture of a cat, the input layer receives the data about that picture, the colors, the shapes, the pixels. Now, the hidden layers. These are where the processing happens. This is where the network identifies patterns and learns. Each hidden layer learns more and more complex features of the data. For example, in image recognition, the first hidden layer might learn to detect edges and lines. The next layer might learn to combine those edges into shapes, like circles or squares. And a later layer might combine those shapes into objects, like a cat's face. It's a complex process. Finally, we have the output layer. This is where the network gives its answer. It's the result of all the processing. In our cat example, the output layer might say, yes, this is a cat. Or no, this is not a cat. So how do these networks actually learn? It's all about adjusting connections. Each connection between nodes has a weight, and you can think of that as the strength of the connection, much like a volume dial controls sound. And each node has a bias, a little nudge in one direction or another, a bit like a light dimmer. It can be adjusted. So, the weight determines how much influence one node has on another, and the bias helps the network fine-tune its overall output. These weights and biases are called the parameters of the network. During training, the network has shown lots and lots of examples. It makes predictions and then gets its feedback on whether it was right or wrong. Based on that feedback, it modifies the connections to get better at making predictions. It's all about trial and error. It's learning from its mistakes, just like you do when you try something new. It's like learning to ride a bike. At first, you wobble and fall. But with practice, you adjust your balance, your steering, your pedaling, and eventually, you can ride smoothly. The network does the same thing, fine-tuning the parameters until it can ride smoothly, or in this case, make accurate predictions. Two other quick terms to mention are regularization and batch normalization. They are tools used in the training process. Regularization helps prevent the model from becoming overly complex, and batch normalization helps to speed up the training. We've covered the basics of neural networks, but there are also some specialized types you should know about. Let's briefly introduce two important ones: RNNs and CNNs. RNN stands for Recurrent Neural Network. It's a type of network that's particularly good at processing sequences of data. Think about data that plays out over time, like text, music, or stock prices. RNNs are special because they have a sort of memory, letting them remember the past inputs. This memory helps them understand the context and make predictions. That's how your phone can predict the next word you're going to type. And another important type of neural network is the CNN, convolutional neural network. CNNs excel at processing images and other visual data. You can think of CNNs as having specialized filters that scan the image, looking for patterns and features. Each of the filters learn more and more complex patterns, starting with simple and getting more complex. This is how image recognition can identify your cat, for example. What's the most interesting thing you learned about neural networks? Share your thoughts in the comments. So, to recap, neural networks are computer programs inspired by the brain, made up of interconnected nodes organized in layers. They learn by fine-tuning the connections between these nodes during training. And they're the driving force behind deep learning and many of the amazing AI applications we see today. Want to unlock the power of AI? Our free newsletter gives you the tips, trends, AI news, and tools you need to succeed. Sign up with the link in the description below. Your journey doesn't stop here. Watch our next video right here and keep building your knowledge.